Alright, let's move on to something that's way less tedious than you can do in your head. This actually should be really, really simple. I'm going to write down the three main laws of logs, and then we'll supplement this as we go along. So, yeah, I'll just write them down, and then we'll use them later on, and I'll come back to them and tell you which ones I'm using. Okay, here we go. We have three laws of logs. If I have log with some base, and I have some multiplication on the inside of the log, I can rewrite that as addition on the outside of the log. So it's like inside to outside, and it changes to addition. So there we go. I have that. That's really useful. And just notice I can go backwards too. If I have the addition of two logs and their bases are the same, then I can rewrite it as the insides multiplied together on the inside. On the inside. Then I have log base b of some type of quotient, some division. I can change that to subtraction on the outside of the logs, as long as I keep the same base in both of them. And then this is called the power rule. If I have a log with something that has an exponent, I can move that out in front. And I actually am going to draw that because people can see that better. And likewise, I can go backwards as well. If I had a coefficient, I could move it back. I mean, this is an equal sign. I can go back and forth. So there you go. Those are the properties of logs, and we're going to use them to expand logarithms and condense logarithms so that we can see what happens. Later on, we'll use these techniques to solve equations involving logs, but for now, we're just going to practice using the properties. So, actually, I want to say one more thing. Sometimes, I'll do it in green. This is the same. This is written as log base b of m raised to the r. That's still the same thing, at least in my interpretation. Some computers interpret it a little bit differently. But if I wanted to have the whole entire log raised to the exponent, I would have to write it like this. So this is not the same if I had something like this. That's completely different. So these two are the same. This is not. So let's move on from there. I'll do a bunch of examples. So here we go. Expand the logarithm. Now I could immediately move the exponent out into the front, but that seems to confuse some people. So I'm going to do that last. That's usually the last thing that I'll do. Right now I can put the exponent, just using my exponent rules, I can put those on both things on the inside. So I would have log base 7, and I actually would skip these steps, but I'm showing you. It's an example. Remember, when you have an exponent and an exponent on the outside of that, you multiply, so this would be y to the 24th in there. And then, so that's just using exponent rules. And then I'm going to use law number 2, where if I have division on the inside, I can change it to subtraction on the outside. So I'll say log base 7 of x to the 6th minus log base 7 of y to the 24th. So I'll have that. And then now I'll use my law 3 to move my exponent out into the front. So I get this moves out and this moves out in front. So those become coefficients. So I have 6 log base 7 of x minus 24 log base 7 of y. And there you go. That's completely expanded. It's very, very simple, very easy. I'm going to stop this video and do more examples in the next one.